On Christmas morning 2021, a $10 billion origami mirror was blasted into space with exactly 344 single points of failure. If just one wire snagged or one motor stalled a million miles from Earth, the most expensive scientific instrument ever built would become a useless piece of space trash. A million miles from any human being. Screws literally falling out on a factory floor. And 29 days of pure psychological terror. How do you engineer a machine with zero margin for error, knowing it must unfold itself in the freezing void a million miles away where no human can ever reach it to fix it? Right now in 2026, the images from this telescope are actively rewriting textbooks. They are pristine, they are effortless, they make the impossible look easy. But the pictures hide the nightmare. The flawless cosmic dawn you see on your screen today was paid for by 3 decades of earthly engineering hell. To understand how close this whole thing came to collapsing, we have to start with the ambition. NASA didn't just want a new telescope. They wanted a time machine. Light takes time to travel. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, 8 minutes ago. NASA wanted to look 13.5 billion years into the past. They wanted to see the very first stars ignite in the universe. But that light is unimaginably faint. To catch it, engineers had to invent a mirror massive enough to gather those ancient photons. A mirror 21 feet across, and it had to operate at absolute zero. If the mirror is even slightly warm, its own infrared heat will blind the sensors. It has to sit at minus 390 degrees Fahrenheit. So they forged 18 hexagonal segments out of beryllium, a rare metal that holds its shape perfectly in the freezing void. But beryllium dust is highly toxic. Just manufacturing it was a massive risk. And there was a bigger problem. A 21-foot mirror and a tennis court-sized sunshield do not fit inside a rocket. The largest payload fairing available was on the Ariane 5 rocket, measuring just 5.4 meters across. You cannot change the size of the rocket. So they had to fold it. They had to turn the most sensitive optical instrument in human history into a piece of $10 billion origami. 5 layers of Kapton film, thinner than a human hair, coated in aluminum, designed to drop the temperature from the boiling heat of the sun down to minus 390 degrees. All folded so tightly it could cram into a 5.4-meter tube. But designing an origami time machine on a whiteboard is one thing. Ensuring it survives the violent acoustic shockwaves of an Ariane 5 rocket launch is another. Because once it leaves Earth, it is entirely on its own. In 1993, the Hubble Space Telescope was launched with a flawed mirror. It was blurry. It was a disaster. But Hubble was only 340 miles above Earth. NASA could send astronauts in the space shuttle to physically bolt on corrective lenses and save the mission. Webb is not 340 miles away. To stay cold enough, it has to orbit the sun, not the Earth. It is parked at a gravitational sweet spot called Lagrange Point 2. 1 million miles away, 4 times further out than the moon. No human being has ever traveled that far. No rescue mission could ever reach it. It had to be perfect on the first try, and in 2018, perfection was falling apart. How do you test a machine for the absolute zero of deep space while it sits in a warehouse in sunny Southern California? At the Northrop Grumman Space Park, engineers were trying to simulate the violence of a rocket launch. They subjected the folded sunshield to a massive vibration test. 140 decibels of pure, shaking acoustic shock. When the test was over, they opened the chamber doors. Screws and washers were literally lying on the floor. The hardware had shaken loose. Tears in the delicate sunshield fabric were discovered. The project was years behind schedule, billions over budget, and Congress was threatening to kill it. Enter Greg Robinson. In 2018, NASA leadership begged Robinson to take over as Webb program director. He inherited a nightmare. But Robinson had a fatal flaw for a government manager, an uncompromising refusal to accept good enough engineering. He demanded an independent review board. He opened the doors and exposed the catastrophic human errors to the world. He forced a massive, humiliating delay. And then he walked into a brutal congressional hearing to beg for a new budget. The final cap was set at $10 billion. There would be no more money, there would be no more delays. If you want to understand how a decade of delays actually feels Zero Future Explained takes apart the realities of these megaprojects every week, hit subscribe. The pressure on the engineers was absolute. thousands of careers hinged on a single, unfixable machine. One engineer summarized the collective paralysis of the entire workforce.
He said, "My daughter was born the year I started designing the sunshield. By the time it actually launched, she had graduated college, and I still didn't know if my life's work was going to actually unfold."
As the launch clock hit zero on December 25, 2021, the earthly engineering was over, and the infamous 29 days on the edge had officially begun. This was the true test. The machine was in the void. It had survived the violent acoustic shockwaves of the Ariane 5 rocket launch, but now it had to unpack itself. Remember that missing $10 billion? We're about to see exactly what it bought. You are watching a screen in Baltimore, the Space Telescope Science Institute. You have 29 days to execute the most complex sequence of deployments ever attempted in space. 50 major deployments, 178 release mechanisms, 344 single points of failure. If a single tensioning cable snaps in the cold of deep space, does a 25-year, $10 billion dream die in the dark? Yes, it does. So they didn't rush. The 344 single points of failure were systematically eliminated through agonizingly slow, remote-controlled motor movements. Day by day, step by step, the sunshield unrolled. The tensioning cables pulled taut, separating the 5 layers of Kapton film by mere inches to allow the heat to vent out the sides. Then, the secondary mirror swung into place on its massive boom. And finally, the golden wings of the primary mirror unfolded and locked into position. 344 ways to die, 0 failures. If you want to understand exactly how those motors were designed to never freeze, hit subscribe. We dissect the impossible every single week. But the perfection of the deployment had an unintended consequence, a beautiful one. The launch and the unfolding were so precise that the telescope barely had to use any of its onboard propellant to correct its course to Lagrange point 2. That fuel was the only hard limit on the telescope's life. By executing a flawless earthly maneuver, they literally bought humanity an extra decade of cosmic discovery. Which brings us back to today, August 2026. The Space Telescope Science Institute in Baltimore processes the daily breakthroughs, and the images arriving on those screens are terrifyingly beautiful. Galaxies that shouldn't exist, black holes too massive for their age. The fundamental laws of astrophysics are being rewritten right now. All because a man named Greg Robinson refused to accept compromised hardware on a factory floor in California. We didn't just build a telescope that survived 344 ways to die. We built a mirror so perfect that, as of 2026, it is actively rewriting the genesis of the universe. But Webb is just the beginning. Right now, engineers are designing a machine meant to go even further, hunting for biosignatures on exoplanets. And it faces a paradox that makes Webb look easy. If you want to see how they plan to solve that, subscribe to Future Explained. We'll see you in the future. Next time, the $600 million whisper that broke physics. Subscribe, you do not want to miss it.